All right, so now we're going to look at the second half of the Unit 4, Chapter 6 review. So this is part 2. For these questions, a lot of it's going to be solve the following equations by any method you choose. I know this says inequalities, but it should say equations. Solve the system of equations using any method you choose. That can be substitution, elimination, graphing, and or Desmos. So what I'm going to do is I'm going to talk about which of the 3 primary methods I might use for the problem, and then I'm going to help you set up that first step. But I'm going to leave the solving up to you. You can always then check the answer key if you want to know the correct answer to the problem. But we're just going to really kind of just set some of these up. So question 13 says 4x plus 3y equals -5 and negative 2x plus 2y equals 6. If I were going to solve this one, I would probably use elimination. And in order to use elimination, I'm going to try to get the x variables to cancel. In order to do that, I'm going to multiply the entirety of the second equation by 2. So this is going to leave the first equation the same way. So 4x plus 3y equals -5. But the second equation is going to change to -4x plus 4y equals 12. And so then our first step in this case would be to eliminate straight down. We see the x's cancel out to be 0. 3 and 4 is going to give us 7y. And then -5, positive 12 is 7. From here, you should be able to solve for y and then plug it back in to find x. I'll leave the rest of the question to you. All right, question 14. We've got 2y equals 2x plus 12 and y plus 3 equals -2x. For me, I would probably use substitution here. And there's really a couple of ways to use substitution in this case. You can rewrite the second equation so it's y equals everything else and plug it into the first, or you could rewrite both equations so they're y equals, so that way the substitution is even easier. Because if you rewrite the first equation so it's y equals everything else, you're really just dividing by 2. So you get y equals x plus 6. If you rewrite the second equation so it's y by itself, you're going to subtract 3. So you get y equals -2x minus 3. To use substitution here, you're really thinking about the fact that you have y equals all of this quantity, and you're plugging it into y in the other equation. So x plus 6 equals -2x minus 3. And then you're going to use your algebra skills to solve for x, plug it back into one of the equations to find y. You could also solve this particular problem by graphing since we've got them both in this form. So graphing might also work. All right, so let's look at question 15 now. Question 15, 8x plus 3y equals 13, 3x plus 2y equals 11. Because of the way these variables align, I'm going to use elimination. And in order to use elimination, I've got to try to get one of the variables to cancel out. So I'm going to actually have to multiply both equations by something here. So what I'm going to do is I'm going to multiply the top equation by 2 and the bottom equation by -3. So I'm essentially changing both. So the top equation is going to become, it's going to become 16x plus 6y equals 26. The bottom equation becomes -9x minus 6y equals -33. So now as we go to eliminate straight down or combine straight down, we've got 16x, -9x is 7x. The y's are going to be 0. And then 23 and -33 is -7. At this point, we can go ahead and solve for x. Once we know x, we'll plug it back in to find y. In question 16, we've got a lot of fractions here. And so one of the things we can do is, first, let's just get rid of the fractions. And we should remember from previously in the year, getting rid of fractions mean multiplying by a common denominator. So in this case, the top equation, we're actually just going to start by multiplying by a common denominator. We're going to multiply the entire problem by 8, since we want to cancel out the 1/8. And then the bottom equation, we're going to multiply the entire problem. Well, 3 and 2, the only thing they have in common would be 6, or the least common denominator here would be 6. So we're going to multiply the entire problem by 6. So that's going to change our equations. We're going to end up with 4x plus y equals 4. And then here we've got 2x minus 3y equals negative 12. Now that we've got this newly arranged problem, we can decide how do we want to solve this. Well, the first equation, if we move the 4x over, we can solve using substitution. So if you rewrite the first equation as y equals negative 4x plus 4, you could use substitution by taking what y equals and plugging it in for y here. That's one option. The alternative to this might be to instead, is to use elimination. So in order to use elimination, you would multiply, in my case, I would multiply, let's say the first equation by 3, so that way my y's cancel. So I'm going to change that first equation, so now it's 12x plus 3y equals 12. With this, I can now eliminate straight down and then solve for whatever variable I might have and go from there. All right, here we have the word problems. And for the word problems, we're just going to set up the equations, and then I'm going to leave it up to you to solve using whatever method you choose. So in this problem, they tell us that a theater sold 900 tickets to a play. For this play, floor seats cost $12, balcony seats cost $10. The total receipts were $9,780. And then they want to know how many of each type of ticket were sold. So for this problem, we're going to have two different types of equations. We're going to have one equation that deals with the number of tickets in general, and then one that deals with the money. So when we talk about the number of tickets, we're talking about floor seats and balcony seats. So let's let floor seats be F, balcony seats be B. So the combination of floor seats and balcony seats should add up to 900 total tickets. When they talk about money, this is where we're going to bring in the dollar amounts. We know that floor seats were $12, balcony seats are $10, and the total there is $9,780. These are your two equations. Now, you could use elimination or substitution. The choice is yours. But for me, I think the easiest approach would be to multiply the first equation by like negative 10. So that way your b variables would cancel out using elimination. But I'll leave that up to you. Question 18. Mrs. Wanamaker, Mr. Witzke, and Mr. Coate and Mr. Johnson all think it would be a good idea to open a Raising Cane's in Marysville. The startup costs to open a Cane's are $500,000. If a box combo costs $429 in materials to make, and then they sell for $749, how many box combos would you have to sell to break even? So right now, this particular problem, when we're dealing with a break even, and especially starting a business like this, we're gonna have two equations. One that deals with the expenses, so the things you have to spend in order to make the business happen, and then you can say like income or profit. So let's talk about expenses. Let's let T equal total money. And then we'll let B equal box combos. So expenses, in order to start the business, the total amount of money spent is equal to the initial $500,000 you have to spend to start the business, plus the $4.29 per box combo. So that's the money that's leaving the business. Then when we sell the box combos, the total amount of money we're making is equal to the $7.49 per box combo we sell. So here we have our two equations. Since both of these equations are set equal to t, this is set up really well for substitution. We're going to take what t equals here and plug it in for t right there. So our first step looks like something like this. We're going to set up an equation that looks something like this, and we're then going to solve for b. I'll leave that for you to solve, and then we're going to look at the final problem that we're going to do on this one together. Question 19. Question 19, you have y is greater than or equal to negative x plus 5, and then y is less than or equal to 3x minus 4. Let's start with the first inequality. To graph this, we're going to put our y-intercept at 5, and we're going to apply our slope. Down one, right one, down one, right one, so on and so forth. Before we draw any kind of line, we're going to take a look at our inequality symbol. In this case, our inequality symbol is a greater than symbol, but it's greater than or equal to. So since it's equal to, we can draw a solid line between our points. Because it's greater than, we would shade above or on top of the line. So we're shading this direction. Now we can go ahead and graph the second inequality. Our y-intercept is 4, or negative 4, sorry. And our slope is 3. So up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. We can then go the other direction to get the other half of our line. This time our inequality symbol is less than or equal to, so that's going to be a solid line so we can connect our points. Since we're equal to, we're including all the values in between. And then it is less than, so we're shading underneath the line. And so remember, with a system of inequalities, we're looking for where the shaded regions overlap. That region would be here, off to the right where they meet. So we're going to shade this in a little bit darker for our final answer. So any point taken from this area represents a solution to that system of inequalities.